Good morning, all of you. My name is LAXMI RATHOD. I'm from Bharati Vidyapit College of Engineering for Women. Our project name is Speech Sentiment Prediction using Deep Learning. We are four members in this project. Me LAXMI RATHOD, Samskruti Wankhede, Tasnim Sheikh, and Preeti Karanjekar. Our project guide is Professor Ashwini Kanade. Next. This is our outline of the project. Introduction, aim and objective, scope, literature survey, software and hardware requirement, system overview, architecture module and diagrams, methodology and conclusion. Next, introduction. Space sentiment prediction has become an active area of research with significant advancement in recent years. Speech emotion detection is the process of automatically identifying the emotional state of a speaker based on their speech. There are few universal emotion we have predict in our project, such as happy, sad, neutral, surprise, and disgust. Next, our aim is to create a system that can accurately recognize, classify, it supports some applications such as emotion recognition in customer service, sentiment analysis in social media, and effective computing in human machine interaction. Our main objective is to design the deep learning model, which is predict the emotion based on the speech. Next, scope of our project is to develop system that accurately recognize and classify the emotional state of speaker based on their speech. The ultimate goal is to create an application that can enhance human machine interaction, improve customer service, and support system analysis in social media, etc. Over to Tasneem.
Before we started working on our system, we done some researches by reading other research paper. We find there were some limitations, like it is based on only two-stage approaches, that is feature extraction and classification, did not train the modules and a really large data set, and also the data set is limited, so we tried to overcome this. This is our hardware and software requirements of this project. System architecture consists of process in which first is pre-processing. In this step, remove any noisy features that could negatively impact the performance of the model. Second step is data augmentation. In this step, it is a technique utilized to enhance the dataset size by creating variations of each input. Data augmentation improves the performance of the model by reducing overfitting. After that, feature extraction is done. In this process, the audio recording are loaded and transformed into MFCC format. In this phase, extract the relevant features from the audio signal. After feature extraction, model generation is created. In model generation, generate the emotion model and save the model. After that, compare the detected emotion with this type of emotion like happy, sad, neutral, disgust, angry, and surprise. This is the architectural module. Next, Sanskriti.
Am I audible? So this is our project data flow diagram level 0. In this diagram, the system is simply processed in the three steps. First, we input the speech as audio, and it goes to the system to detect the emotion. And in the third step, uh, it categorizes the emotion. Next. This is the data flow diagram level 1. In this system, we input the speech as audio and it passes through the three steps like pre-processing, then it goes to feature extraction, then it classifies, and then gives the output. Next. This is our use case diagram. Uh, in In this system, firstly user have to register for our system and then log in. After that, user have to upload this page as an input as user, and a user will view the emotion stage. Then user has to log out the account. Now the system work is the system will handle the login details and input details means they can what user is input the audio, it will gather, then it goes to pre-processing. After pre-processing, it will model the trail and generate the model and gives the stage prediction and give the output in emojis text. Let's, let's This is activity diagram. In this diagram, the input is so we input this speech as audio. Then first we pre-process means the unwanted voice will remove in this process. After the pre-processing, the feature extraction will happen. In feature extraction, the relevant feature will extract by using MFCC. After the feature extraction, the model will train and the decision we will get in the emojis, text, and audio clips. Yeah. Next,
Yes.
this is the state diagram. Here, the user will log in, then it will check the authentication. If he is authenticate, then it will go to the next step that upload speech, then emotion will predict and he will log out. If he is not authenticate, then it will go back again to login. Next.
Then methodologies. LSTM, it is a long short-term memory. LSTM can be classified, process, and predict the data. It can help to remove unwanted voice. LSTM addresses these problems by introducing for an extended period of time. This memory cell is controlled by three gates. Next, in three gates, the input gate, forget gate, and output gate. These gates decide what information is added to remove from and output from the memory cell. The input gate controls what information is added to the memory cell. The forget gate controls what information is removed from memory cell, and the output gate controls what information is output from memory cell. Next, MFCC. It is a male frequency crystal coefficient. ML extract features from raw data and create representation of the content. This forces us to learn the core information without noise to make inferences. Back to speech recognition, our objective is finding the best sequence of the words corresponding to audio model dataset. The CREMA D is a dataset of acted emotional speech and facial expressions. The dataset consists of audio visual recordings of 91 professional actors performing 12 sentences in 7 different emotions like anger, disgust, fear, happiness, neutral, sadness, and surprise. Next, in conclusion, we are conclude to detecting emotions through speech using based on deep learning. LSTM algorithm is used to analyze speech signals and extract features of MFCC. Emotional recognition using MFCC approach in functional network. Then it is the complex speech signals and recognizing emotional patterns to detect the effectiveness of deep learning algorithms. Then the result of this system show its effectiveness in achieving good results. Next, these are the references we are using in our project. So thank you for giving me this opportunity to present our project.